Let me briefly explain our paper, Zipfian Whitening. If it catches your interest, we encourage you to dive into the full paper. First, let's go over the background. There are various types of language models, including Word2Vec, BERT, and causal language models. It is known that all these models exhibit skewed word embedding layers, and correcting this skew improves performance on downstream tasks. Upon closer look, centering and whitening implicitly involve calculating expectations. This means that instead of simply averaging the set of word vectors, it feels more appropriate to weight them by word frequencies. Our very simple proposal is to consider word frequencies when calculating expectations. These two approaches differ significantly because language data follows a highly non-uniform distribution. For example, the power law distribution of word frequencies is known as Zipf's law. By following these simple guidelines to adjust the word embedding space, we achieve incredible performance gains on typical NLP tasks. Plus, these results are consistent across various models, from classic word vectors to the latest language models, as well as across several tasks and multiple languages. Naturally, this raises the question, why are these dramatic performance improvements happening? Here is our conclusion. The difference between the uniform approach and the Zipfian approach can be characterized by their underlying generative models. All types of language models, in essence, predict a word W based on a context C. To do this, they learn latent vector representations for both context and word. The uniform approach corresponds to the familiar generative model that uses inner products and softmax. On the other hand, the Zipfian approach aligns with a generative model similar to contrastive loss, where the word frequency P of W is in the numerator. Although it's a bit simplified, processing the word embedding layer in a uniform manner brings it closer to uniform generative models. Similarly, processing it in a Zipfian manner brings it to Zipfian generative models. Based on what we have discussed, our more precise research question is, why does the Zipfian approach perform so well on natural language processing tasks? This is because the Zipfian generative model has the ability to emphasize informative words. In NLP and information retrieval, methods like IDF prefer to highlight low-frequency, informative words. For example, if we want to determine the topic of a sentence, knowing that it contains the word of is not very helpful. On the other hand, knowing that it contains the word isotropy, which is much more useful. This can be explained by looking at the lengths of the vectors. In a Zipfian world, informative words end up having longer vectors. This nice feature does not occur in a uniform world. For a theoretical explanation from the perspective of information geometry, please refer to our paper. You will also clearly see this in our experiments. This can also be explained in terms of loss and error. For the uniform generative model, the corresponding loss is the well-known softmax cross-entropy loss. This loss is related to misclassification error, which means it tends to emphasize high-frequency words. On the other hand, the loss associated with the Zipfian generative model is known as logit adjusted loss. This loss corresponds to balanced error and actively emphasizes informative words in proportion to their information content. Here is the summary. We hope you enjoy our paper.